As you grow the number of workloads that run in AWS, you must be able to scale your network across multiple accounts and VPCs to keep up with that growth. You can use VPC peering to connect pairs of VPCs. However, it can be operationally costly and difficult to manage a point-to-point connectivity, specifically that each VPCs need to make a specific point-to-point connection. The same IP address that you use for VPC A is not going to be repeated in the second VPC, which is VPC B. If you cannot centrally manage those connectivity policy, it will be very, very difficult to keep up with multiple connections. So when you have an on-prem connectivity, you must attach your VPN to each individual VPC. And this solution can be time-consuming to build and very difficult to manage when the number of VPCs grows into the hundreds. So it is very important to consider how large your environment might become over time and how well it will scale and how you will organize your VPCs. To solve this problem, you can use the AWS Transit Gateway, which can simplify your networking module. So what is AWS Transit Gateway? Transit Gateway is a service that enables you to connect your VPC and on-premises networks to a single gateway. So it will be a single hub of connection. It is a fully managed, highly available with flexible routing services. It can act as a hub for all traffic to flow through between your networks. You can connect up to 5,000 VPCs and on-premises environments with a single gateway. So let us look to a scenario where we have to connect multiple VPCs. To connect multiple VPCs using AWS Transit Gateway, consider this scenario. You want to fully connect 3 VPCs in your network. You learn how to deploy AWS Transit Gateway and the 3 VPCs with non-overlapping IP address, and make sure to remember that, guys, in the exam. Those non-overlapping IP addresses must be in a single region. You then attach the transit gateway to these VPCs. So the first step for connecting multiple VPCs is to create a transit gateway. That transit gateway will act as a hub that you can use to interconnect your VPCs and on-premise data center. The AWS Transit Gateway in this case will need an elastic network interface, which are deployed into the subnet. So as you can see here, in each VPC1, VPC2, and VPC3, we have a specific network interface that we are going to use. You must ensure that every availability zone that is part of the VPC has that ENI. Now, after you do attach the ENI, the next step is to add a route to the VPC route table to send the traffic, which can be destined for other VPCs in the network to that transit gateway. So you can see here, VPC3 route table, we are saying the IP address 10.0.0.0/8. The target is TGW Transit Gateway. If you notice here that this network, the 10.0.0/8, included in it everything we need for the other CIDR block. It has the IP 10.2.0.0 and 10.1.0.0. You must now configure the transit gateway route table to route traffic to the connected VPC. In this table, when you create a transit gateway, in that default transit gateway route table, each route in the transit gateway must enable the transit gateway to send the traffic destined for one of the VPCs to a corresponding attachment. So you can see now in the transit gateway route table, we are saying if you want to reach 10.1.0.0/16, then you need to go to VPC attach 1. If you want to reach 10.0.3.0.0 with a /16, the VPC will be in the VPC attach 3. You can use the AWS Transit Gateway to connect multiple VPCs. You can also use it to achieve isolation in your VPC environment. In this particular scenario, you want to connect your VPN source to your VPC environment. You want also to prevent your VPCs from directly connecting to each other, leaving the VPN to decide if the traffic from one VPC has to be forwarded to another. By setting up the route table in an appropriate way, the transit gateway, you can prevent information sharing between those VPCs. So as you can see here in this diagram, we have a VPN connection and we want to update the route table in the transit gateway to send all unknown traffic to that VPN connection. In this particular scenario, we are going to put in the transit gateway route table for any other IP, the target will be the VPN connection. So this is how you create an AWS transit gateway and achieve a VPC isolation. In this activity, you have 5 VPCs that you want to connect to each other through AWS transit gateway. You can go and start to think what routes are necessary to add each of the VPC route table to enable full connectivity, and what routes are necessary to add to the transit gateway route table to enable full connectivity. And you will find that in the VPC3, for example, we are going to say any traffic that distant to 10.0.0.0/8 go to the transit gateway, because this IP is the address summarization for all VPCs that we have in this diagram. You can also look that in the transit gateway route table, we are going to specify each VPC subnet ID, and we specify the VPC attachment to be the target of that traffic. Now, what about if we want to connect our VPCs to a supported AWS services? The first thing you want to think of is VPC endpoints. And this is really important for the exam. They would love to ask about VPC on endpoint all the time. A VPC endpoints enable you to privately connect your VPC to supported AWS services and to VPC endpoint services that are powered by AWS Private Link. The endpoint, which are powered by the AWS Private Link, include some AWS services, and those services might be hosted by other AWS customer or even an AWS partner network. The VPC endpoints do not require an internet gateway or a NAT device or a VPN connection or a DX Direct Connect connection. Instances in your VPC do not require public IP address to communicate with resources in the service, and the traffic between your VPC and other service does not leave the Amazon network. Those endpoints are virtual devices. They are horizontally scaled, redundant, and highly available. Endpoint allow communication between instances in your VPC services without imposing availability risk or bandwidth constraints in your network traffic. In AWS, there are 2 types of VPC endpoint. There is the interface endpoint, which is an elastic network interface with a private IP address. That IP address serves as an entry point for the traffic that is destined to a supported service. Interface endpoints enable you to connect to services that are powered by AWS privately. Normally, the owner of the AWS service is the service provider, and there is the principal who basically create the interface endpoint. You are the service consumer. The second type is the gateway endpoint. The gateway endpoint is a gateway that you specify as a target for a route in your route table, and the route is for traffic that is destined to supported AWS services like Amazon S3 and Amazon DynamoDB, which are supported both by gateway endpoint. In VPC endpoint, guys, there is no hourly or data processing charge. You will be billed for each hour that your VPC endpoint remain provisioned in each availability zone, regardless of the state of its association with the service. The hourly billing for your VPC endpoint will stop when you delete it, and the hourly billing will also stop if the endpoint service owner rejects your VPC endpoint attachment to their services. For doing the exam, make sure you understand the 2 types of VPC endpoint, and make sure to remember that Amazon S3 and Amazon DynamoDB are supported by gateway endpoint, not an interface endpoint. How you set up an interface endpoint? To set up an interface endpoint, follow these general steps from the Amazon VPC console. Specify the name of the AWS service, endpoint, services, or the AWS Marketplace service you want to connect to. Then choose the VPC where you want to create the interface endpoint. You can specify more than one subnet in different availability zone. Doing so helps you to ensure that your interface endpoint is resilient to availability zone failures. Choose a subnet in your VPC that will use the interface endpoint. Enable a private domain name system for the endpoint if you are going to use a gateway, and this will enable you to make requests to the service by using its default DNS name. Specify the security group to associate with the network interface, and that security group rules will control the traffic to the endpoint network interface from resources in your VPC. If you do not specify a security group, the default security group of the VPC, remember that, guys, it will be the VPC itself security group which will be implemented to the VPC endpoint. This is an example about how you can use the VPC. When you create an interface endpoint, the endpoint specifies DNS host names which are generated that you can use to communicate with the services, an AWS service and AWS Marketplace partner services, and also a private DNS option which can be enabled by default. In those example, you will see that the hosted zone contains a record set for the default DNS name. Now, guys, remember here, the hosted zone is the route 53. So if you are not familiar with the concept of hosted zone, go back and see the demo doing the route 53 and how you can create a hosted zone and configure a DNS record. So in this particular scenario, the hosted zone will create a record set for the default DNS name for the service. For example, you can call it a kinesis.useast1.amazon.com, which resolves to the private IP address of the endpoint network interface. And this enables your application to make requests to the service using its default DNS host name instead. This allows your existing application to make requests to an AWS service through the interface endpoint without requiring any configuration changes. In this example, there is an interface endpoint for Amazon Kinesis data stream and an endpoint network interface in subnet number 2. Private DNS for the interface endpoint has not been enabled, and instances in either subnet can send requests to Amazon Kinesis through the interface endpoint using the endpoint specific DNS host name. Instances in subnet 1 can communicate with Amazon Kinesis data stream over that public IP address. There is also another example where you can use a private DNS for the endpoint, which can be enabled via the same way. In instances in either subnet can use either the default DNS host name or the endpoint, the specific DNS host name to send requests to Amazon Kinesis data stream through the interface endpoint. So by this, we finished module 7. So make sure to review those guys before you go to the solution architect exam, which are the on-premise network of the cloud, connecting VPCs. You connect VPCs in the AWS cloud by using a VPC peering, and describe how to scale VPCs in the AWS and how to connect VPC to supported AWS services.